So that gives us y dy on this side. And then when I multiply by the x, that's going to give us 2x dx. Okay, now we've got this side in terms of y, this side in terms of x, so we can integrate each side, okay? So remember, integration is just an operation, so we can do it like we would add something, we subtract something. We're going to integrate both sides. So if we integrate this side with respect to y, okay, notice we're with respect to y, so you don't have to deal with like the y primes and all that business. It's all in terms of y. So if we integrate a y, okay, remember you add 1 to the exponent and divide, so that's going to give me 1/2 y squared equals, if we do this side, and the 1 divide, that's going to give me x squared, and we're just going to put a plus c on the side with the x. Technically both sides have a plus c, but if you're adding a constant to both sides, then you'd have a constant minus a constant, and that all cancels out anyway. So just put the plus c on one side, usually the side with the x, and away we go. Okay, so now we want this in terms of y equals, so we want to get this y by itself. So I'm going to multiply this side by 2. And I'm not going to multiply the constant because we don't know what the constant is anyway. So if we multiply the constant that we don't know by 2, we still just have a constant. So that's still just going to be that. And then this is y squared, so we're going to take the square root. Don't forget, when you do a square root, that gives you plus or minus. And we're done. Okay, so that tells me that the differential equation dy dx equals 2x over y. If you're looking for the original equation that we took the derivative of, it was y equals plus or minus the square root of 2x squared plus some constant c. So this function right here, if we drew a slope field like we were doing yesterday, would give us the slope field for this equation, okay? And that plus c is why the slope field is that whole grid where you can kind of trace your way through, but it's not necessarily the same thing every time, okay? So see, it's pretty simple. Separate the variables, integrate both sides. Let's look at number 2. This one doesn't have an x over here, so we just need to get the y squared with this guy, but we still need to move the dx over. So this is going to end up being dy divided by y squared equals 1 times dx. Okay, well this over y squared, no, it's not natural log. It's just y to the negative 2, right? So this is really y to the negative 2 dy, and we're going to integrate both sides. So if we integrate y to the negative 2, add 1 is negative 1, divide is negative 1, that gives me negative y to the negative 1 equals x plus c. Easy enough, right? Okay, so then we need to divide by negative 1 to get rid of the negative. So that leaves me with 1 over y equals negative x plus c. And again, we're not going to change the plus sign because we don't know what the c is anyway, so we're just going to leave it alone. Okay, so this is an inverse, right? It's a reciprocal, so it's 1 over y. So if we raise this side to the negative 1 power, that's going to flip this guy over. So we're going to do the same thing over here. And I know that's a weird math term and you're going to be mad at me for doing magic math, but it looks like that. So this 1 over y to the negative 1 gives me y. And if I flip this, this gives me 1 over negative x plus c. So you're essentially just reciprocating both of your fractions. So it looks like that. So again, this is the function that stems from this. Okay, so hopefully this is making some sense. Here we go. Looking at number 3. I've got dy dx, so we're going to separate them again. So this is all in terms of x, so I'm going to multiply by dx. This is in terms of dy, so I'm going to multiply by that. So that gives me 3y squared dy equals x plus sine x times dx. Okay, again, integrating both sides. Integrate. Integrate. Okay, so if we integrate 3y squared, add 1 to the exponent and divide, this gives me y cubed. Okay, this has 2 different pieces, so if we integrate the x, that's what, 1/2 x squared, and the integral of sine is going to be negative cosine plus c. Don't forget that plus c. So this is y cubed, so this is easy. Just take the cube root of both sides, and remember when you're doing odd roots, you don't need the plus or minus. So this is the cube root of 1/2 x squared minus cosine x plus c. And all of that's underneath that radical. Okay, hopefully we're still doing good and you're hanging in there with me. Look at number 4. Let's finish this row and then I'll skip to another video so you can process for a second. Okay, so this is going to be, we'll leave the 4 because we really only need to get rid of the y. So we'll move the y over. So we need to divide by the y. So this is dy over y equals 4 dx. You could have moved the 4 with the y, but typically they leave the constants on the side with the x. So we'll leave it like that. So let's integrate both sides. Okay, so the integral of dy over y is natural log. So this is going to be the natural log of the absolute value of y, because we don't know what y is, so you have to have that absolute value in case it's a negative. If you integrate the 4, that's 4x. No, that's not 4x. Yeah, that's 4x. I don't know. I'm having issues. So that's 4x plus c. Okay, this is the part that you're really not going to like. So remember that this natural log has a base of e that's like an imaginary e that's like invisible. Okay, so we've got to get this y by itself. So to do that, we have to do the swirl. We have to exponentiate the function. So that means that y is going to equal e to the 4x plus c power. Okay, that's probably not the part you're not going to like. Remember what addition means when you're dealing with exponents? Addition when you have exponents means that you took the two bases originally and multiplied them together. So this e to the 4x plus c